Hi, in this lecture, I'm going to talk about debugging. I think most of you now have a chance to write some Python 3 code and you might have run into some problem. So you're going to debug your code. Debugging is a process of finding and correcting bugs or error in the program. Just like programming in general, debugging need to be learned through experience. And I said it before, debugging is like a detective work. You are confronted with clues and you have to infer the processes and the event that led you to the result that you see. You see something doesn't work, but you have to take a look. How do you get the answer? How the program get the wrong answer? And once you have the idea what is going on, what's wrong, you modify your program and try again. This is like an iterative work until you fix all of the bugs. And just like most people say, prevention is the best medicine. This also applies to the programming situation also. Prevention. Prevent errors by programming correctly. Again, learn the programming syntax and semantics. Program in such a way that it is easier to locate and correct error if they do occur. In most development environment, like in a company, in a big project, they have what they call coding standard. By following coding standard, it is less likely um, you're gonna have a bug, and if you do, it'll be easier to see where the problem is. Prevention. Well, plan ahead. Think about the structure of your program before you start coding. You're gonna see most of our program written are IPO, input, process, output. They follow in this order. You prompt user for input, you do something with the input, and then you display the output. You write your program and test small part of the entire program. In a lot of cases, you can just run your code after writing a few lines of code where it may not seem logical at that point. This is the incremental development. Again, I talk about IPO. You could do the input statement first. Just prompt user for input, just to make sure there's no syntax error. Do something with the input. Once you figure out that no syntax error for input, process, and then if the process no error, then you do the output, kind of like display the output, and then maybe make the output look better. So little by little, do not try to write the program all at once and run the program all at once. You are just asking for failure. Follow good coding style. If you consistently use good style, you are less likely to make the mistake and they will be easier to track down later. Finding errors, well, you have syntax error. Syntax error is um, maybe misspell word or you forget the double quote not matching curly braces or many other things where Python consider be um, wrong syntax. And when you have a syntax error, the program will not run, which is good. You can find out where the error is and fix it. Runtime errors is the program crash and Python give you a message about describing the error. Um, I can tell you like divided by zero, our bind index, those are type of runtime error. Semantic errors, this one is a little bit harder to figure out, especially in a larger project. That is, your program works sometimes, but it doesn't work sometimes also. Your program may not give you the right answer. There's no syntax, no runtime error, and it could be working sometime. It could be not working sometime. It could be giving wrong answer. These are a little bit harder to track down. And again, if it doesn't give you the right answer, right result, track down how you get the result and kind of work your way backward to find where the problem is. Again, syntax error, you violate the rules of the language. like print, quote, hello there, quote, you're missing parentheses. By the way, this print statement will work in the Python 2, but it will not work in the Python 3. Assignment statement, 3 plus 5 equal to value. You know that assignment statement, the left-hand side of the equal sign, which is assignment operator, had to be a variable. Right-hand side is an expression. You may not know the for loop yet, but in this statement, for I in range 10, colon, total equal to total plus I. This is actually a valid statement, except, well, total was not defined yet. If the variable had not been defined, you are trying to increment the variable, it will not work. And what is wrong with this code? Can you identify the problem with this code? Find out in the lecture. Another type of syntax error, indentation, the type mismatch, combining string and number, unclosed bracket, parenthesis, curly braces, square bracket, unmatched quote, keyword, a variable or function name. You can find a lot by Google and Python error, but if you do encounter error, I want you pay close attention to the error so you understand why you get those errors and know how to avoid those errors in the future. Runtime error, program syntax correct, but when you execute, program error. What's wrong in this code? Um, total equals 0, count equals 0. For I in range count, total equal to total plus I. You might not know what this program does yet, but look at the last statement. Total get increment or update in the loop. But how about the average? How about the for loop? What do you think is going to happen to the average? Think about that. I will talk more about this in class. Program semantic error is a program is syntax correct and no runtime error, but the output is not expected. Points to earn is 150. Points earned, I asked I asked the user enter points earned, and score percentage is points earned divided by 100. Can you spot the error? What's wrong with this code? One way to find bug is you have to run tests. Test your program for errors. And this is probably one of the most important part of the debugging. How do you know you have a problem if you do not test your program? And when you test a program, do not just say run test and see the correct answer and say I'm done. You want to test with a different type of input to make sure your program output correctly. So your program may function correctly with some general case, proper input. It may not work for all other cases, special or boundary cases. Improper input. Improper input, part one of the thing, um, you want to validate the input correct, because if you have a wrong input, and later on your program going to crash because of the improper input. And once you have an error, thing that you should try is be methodical about it. If you start banging away problem without thinking, you're going to less likely cause more problem than yourself than trouble. You know, write down the step. Think backward from the output. Walk away backward to see how the program, why the program get those results. And if you get stuck, take a break, get some sleep. And after a certain point, you're just not being productive anymore. Okay? And you can also use print statement to see what's going on. Print out messages can help you understand where the program is. So use the print statement to print maybe the value or the intermediate variable value just to see what's going on. But be descriptive when you add the print statement. Maybe before input, after input. And don't put like a, 1, 2, 3 or something that can't use as message. You are going to debug in the program. You might as well add some descriptive message to help you to decide how the program works. We've been writing very simple program, but the program will get more complicated because your program will make decision, your program can do loop, we can use function and all this. So be methodical about debugging. Break the program apart to locate the error. If you if you cannot locate the errors, maybe you want to rewrite the code a little bit, break it, and just to see which part could be the problem. Simplify the problem may also help. You can test the program with smaller list, simple test cases first. If the program works with a simple one, which is good, but doesn't work with more other type of input, then you know what type of input causing problem, and then work your way to figure out where the problem is. Simplify complex line by breaking them apart into multiple line. If you have some statement which is complicated, break them apart, make it easier on yourself. And after fixing the bug, it's worthwhile to think about what happened and why it happened. A lot of bugs occur because of simple typos, but a lot are caused by programmer's strategy. This is kind of like your reflection. Why do I run into a problem? How do I not run into a problem again? You want to learn from those lessons. The more you learn from the debugging, the less likely you're going to run into a bug again. And if you do, you know what to do with it.